Yes, sir.
Okay, good morning to one and all. Today we have to continue with this particular gas chromatography. In the gas chromatography, in the last lecture, we talk about the basic components of the gas chromatography. Then we have talk about the different components and different that particular parts which are most important. In that, one of the very much important part is the detector. And I said there are the three types of the detectors. One is the flame ionization detector, second is the thermal conductivity detector, and third one is the electron capture detector. These three detectors are there. If the offline exam is there and the subjective question is there, then the 5 marks question comes on this particular detector separately. In that, you have to write about that detector. In the detector, the block diagram is expected, then the principle, then construction and working is required. Okay, then we will see. Just I'm sharing my presentation. In that, we will talk about in more detail about this particular. Yeah, it is visible.
Yes, sir.
Yes, sir.
Okay. First detector, the question is like that. Explain the flame ionization detector in the gas chromatography and give one advantages. This is the 5 marks question comes in the exam. In that, the block diagram is shown to you. You can see here the effluent means what is the effluent that coming from the capillary. Okay, it will goes to this particular flame. Here the hydrogen flame is there. Okay, because you can see the hydrogen gas and the air is there, means the oxygen is there. Okay, they burn at the tip. Okay, then the electrode is there. Whatever the ionization will be there, that will detected by this electrode, and it is connected to this particular circuit. There is a power supply, then the amplifier, and finally you will get the record, that signal recorder is there. Okay, other that flame है आपको पता है, then there will be the burning will be there, and whatever the that you can say uh, the fumes are there that can be exhausted from this particular pipe. What is the basic principle in that is that you see the effluent or whatever the elution coming from the or the sample coming from the capillary is burning on the flame. Okay, means what will happen in the burning at the time of when you are coming in bringing that in contact with the flame, at that time there will be the ionization, means whatever the sample is there, it will convert into its own ion. Are you getting this point? Means what will happen when they come, जब कोई effluent है, that effluent comes to the flame, at that time it will burn होने के बाद क्या होगा, there will be the separation of the ions, dissociations of the ion. Okay, and whatever the ions are there, आपको पता है कि ionization होता है, मतलब it is related to again the electron. Okay, and it will ultimately gives you the current production. This is the ionic current, not the electronic current. Are you getting that point? ये क्या है, ionic current है. क्यों ionic current है? Because whatever the molecule, whatever the sample is there, it is going to convert into its own ion. That may be the cation or say anion. Okay, working, the detector has inlets for the hydrogen gas, air, and oxygen to burn the hydrogen and effluent gas from the column. Hydrogen emerges through a hollow needle and is burned and give a colorless flame. The effluent gas is mixed with the hydrogen and mixture burn at excess of air. The thermal energy of a flame is sufficient to cause the ionization of molecule in the effluent gas. When the ion forms, current increases, which is amplified and recorded. The ion current is proportional to the number of carbon atoms which enter the flame. here you can see the another diagram is there, very simple working is there. क्या कर रहे हैं हम लोग कि एफ्लुएंट को पास कर रहे, इनलेट है वहां पे हाइड्रोजन गैस के लिए, ऑक्सीजन के लिए मिक्स होते हैं, बर्न होते हैं। आपको मालूम है कि फ्यूल और ऑक्सीडेंट, हाइड्रोजन गैस क्या है, फ्यूल है, और ऑक्सीजन क्या है, ऑक्सीडेंट है एयर। ओके, एक कॉलम से आने वाला एफ्लुएंट यहाँ पे चला गया, बर्न होने वाला है, फ्लेम पे जाने वाला, यहाँ पे एक इलेक्ट्रोड है। ओके, एक पॉजिटिव टर्मिनल को कनेक्ट किया, एक नेगेटिव को है, यहाँ पे फ्लेम बर्न हो रही है, आयोनाइजेशन हुआ है, आयन जाएंगे वहां पे फिर बाद में क्या होगा, ये जो कुछ भी इलेक्ट्रिकल सर्किट है उसको एम्पलीफायर को कनेक्ट किया है, एम्पलीफायर एम्पलीफाई करेगा और आपको क्या देने वाला है, सिग्नल। आर यू विजिबल दिस डायग्राम?
Yes, sir.
It is more specific diagram. Okay, that is a block diagram which is present in your book. Okay, and it is I taken from the net. Okay, it gives the very specific things. Here the current measurement is taking place. Okay, how that current measurement taking place, you can see. I said what you have to remember कि क्या होता है। प्रिंसिपल में तो हमने एक लाइन में लिखा है, मगर वर्किंग में कैसा होता है कि इनलेट से दोनों गैस जाते हैं, हाइड्रोजन जाता है, ऑक्सीजन जाता है, वो कॉलम से आने वाले एफ्लुएंट के साथ मिक्स होता है। ओके, एक्सेस ऑफ ऑक्सीजन में वो बर्न होता है, फ्लेम प्रोड्यूस होती है। फ्लेम क्या करती है, उस सैंपल को, उस पर्टिकुलर आए हुए एफ्लुएंट को आयोनाइज करती है। ओके, आयोनाइज करने के बाद दे विल फॉर्म द आयंस एंड दैट आयंस आर रिस्पॉन्सिबल फॉर प्रोडक्शन ऑफ द करंट, and current whatever the produce is proportional to the carbon atom entering the that particular flame. अभी advantage क्या है, it is a simple and easy to operate and it is a highly sensitive, and disadvantage is that it destroys the sample. Use of the hydrogen gas for the flame production can be proved to be hazardous. It does not respond to inorganic compound, water and air. These are the inorganic compound. There is no carbon. कार्बन की जरूरत है इस पे, ऐसे इधर यहाँ FID की, that is an basic requirement. Second detector, another question comes on this particular part is explain the thermal conductivity detector in the gas chromatography and give one advantages. This type of question is coming in again the exam. Okay, here the block diagram is shown to you. You can see the thermistor are there. अब इधर thermal conductivity detector है. Thermal in the sense there should be the temperature producing something, things will be there. You can see here the block diagram is very much simple. Here it is a Western bridge formation is there. You can see the 4 different thermistors are there, T1, T2, T3, T4. They are arranged in the particular manner. Okay, there are the inlet for the pure carrier gas and carrier gas plus effluent. Okay, 2 inlets are there, then the outlets are there. Okay, in between that heat metal block is there, and which forms this totally 4 thermistor forms the Western bridge. The most widely used detector in the gas chromatography. It is an most widely used detector in the gas chromatography. It measures the ability of the substance to conduct the heat and also measures the changes in the thermal conductivity of the carrier gas and use it to identify the solid. The change in the thermal conductivity will change the temperature of thermistor. Less is in contact with the gaseous stream, which affect the resistance in the Western bridge circuit. It creates an balance in circuit, leads to the production of the current, which is amplified and measured. The current produced is proportional to the change in resistance, temperature, thermal conductivity and the amount of the solute. is जो है that will proportional to the change in resistance, temperature, thermal conductivity and amount of the solid. This is the principle of the this TCD. TCD क्या है देखो, it is again the very simple. I said कि sample जो है वो जाएगा वहाँ पे, टेम्परेचर हम मेंटेन करने वाले हैं, वहाँ पे विस्टन ब्रिज फॉर्म होता है, आपको पता रहना चाहिए T1, T2, T3, T4। ये जो 4 थर्मिस्टर है वो क्या किए हैं, दे मे बी अरेंज इन द पैरेलल और से व्हाटएवर द पर्टिकुलर अरेंजमेंट, विस्टन नेटवर्क फॉर्म होता है, वो एक दूसरे के अपोजिट में रहते हैं, जैसे कि T1 के अपोजिट में T3 रहेगा, T2 के अपोजिट में T4 रहेगा, लाइकवाइज दैट। ओके, ऐसा एक विस्टन ब्रिज फॉर्म होता है। और उस ब्रिज फॉर्म होने के बाद में व्हाट विल हैपन कि आपको पता है कि हम हीट करने वाले हैं, बराबर है, सब्सटेंस को क्या करने वाले हैं, हीट करने वाले हैं। तो वो सब्सटेंस क्या करेगा, वो हीट एब्जॉर्ब करेगा और हीट एब्सॉर्ब करने के बाद वो क्या होगा, इट इट हैज सम मोबिलिटी। ओके, मतलब क्या होगा कि हर एक के पास में एक एबिलिटी होती है हीट कंडक्ट करने की, बराबर है। अब हीट कंडक्ट करने के बाद वी विल कॉल इट एज अ थर्मल कंडक्टिविटी। दैट विल बी, जैसे कि हम टेम्परेचर जो चाहिए वो वहाँ पे सिलेक्ट करने वाले हैं बराबर थर्मिस्टर का, तो उसके हिसाब से थर्मल कंडक्टिविटी भी वैरी होने वाली है, और से चेंज इन द थर्मल कंडक्टिविटी विल चेंज द टेम्परेचर ऑफ द थर्मिस्टर। ओके, जैसे कि थर्मल कंडक्टिविटी चेंज होती है तो थर्मिस्टर का टेम्परेचर भी चेंज करने वाला है, और वो बैलेंस हो जाता है थर्मिस्टर, मतलब व्हीटस्टोन ब्रिज में क्या हो जाएगा, बैलेंस हो जाएगा। आफ्टर द बैलेंसिंग ऑफ दिस थिंग द करंट इज प्रोड्यूस एंड दैट करंट विल बी एम्प्लीफाइड एंड मेजर्ड। Construction and working, this particular instrument is having named the cathometer. The instrument used is known as the cathometer. Here the more specific things are there, you can see over here. It has thermistor made by fusing oxides of the metal. The carrier gas is used helium, hydrogen, nitrogen. Nitrogen gas is preferred because helium is costly and hydrogen is dangerous. In detector, two pairs of the matched thermistor from the Wheatstone bridge circuit, one arranged as shown in the figure. आपको जो जैसे फिगर में दिखा है वैसे वो अरेंज करते हैं। कैरियर गैस इज पास ओवर वन पेयर, जिसे हम रेफरेंस कहते हैं, यहाँ पे मैंने दिखाया है। while a mixture of gas and a column will pass over the other pair, जिसे हम सैंपल कहते हैं। यहाँ पे आपके पहले डायग्राम में यहाँ पे देखो, एक तरफ से क्या जा रहा है, प्योर गैस जा रहा है, दूसरी तरफ से क्या जा रहा है, सैंपल जा रहा है। दिस डायग्राम इज मोर दैट इफेक्टिव। ओके, देन when pure carrier gas passes over both the pair of the thermistor, bridge is balanced. When the pure carrier gas passes over one pair on a mixture of the carrier gas and effluent over the other, the bridge is unbalanced because of unequal cooling of two pairs of thermistor. क्या होता है कि एक तरफ से प्योर गैस जा रहा है तो बैलेंस रहता है। ओके, अगर हमने एक साइड से प्योर गैस छोड़ा और दूसरी साइड से प्योर गैस प्लस क्या छोड़ा है, सैंपल, तो आपको unequal cooling will be there, and the extent in imbalance is measure of the concentration of the column effluent in the carrier gas. Okay, then the imbalance is fed to a recorder to give the chromatogram. अभी क्या करते हैं, that I will say you see here, you're passing one from the one pair, मतलब ये दो दो one pair मतलब क्या, दो थर्मिस्टर है, यहाँ से हम एक साइड से प्योर गैस पास करने वाले, दूसरे इसमें प्योर गैस प्लस सैंपल। तो ये क्या हो जाएंगे, जब ये दोनों हम साइमल्टेनियसली पास करेंगे, एट दैट टाइम ये थर्मिस्टर का टेम्परेचर क्या होने वाला है, चेंज होने वाला है। ओके, चेंज होने वाला है, तो चेंज होने के बाद में व्हाट विल हैपन, इट विल क्रिएट द इम्बैलेंस, एंड दैट व्हाटएवर द इम्बैलेंस इज देयर, दैट इम्बैलेंस विल गिव्स यू द that particular what we can say, the concentration, that whatever the extent of the imbalance will be there, it will nothing but a concentration, it will correspond to the concentration of the column influent in the carrier gas, and this imbalance, whatever the imbalance is coming, it will gives to the that particular what we can say, the recorder, and which will gives you the chromatogram. Disadvantage, advantage, simple to study and easy to operate. It can determine the concentration without destroying the sample. It responds to both organic and inorganic species. It is less sensitive as compared to the other detector. ये less sensitive है. These are the two detectors which are very much important. Another third one we will see in the next lecture. 5 marks question generally comes in the exam based on this detector. Out of this 3 detector, one detector is coming 101%. Okay, 101% वहाँ पे रहता ही है. Anybody is having any doubt regarding this part, you can please ask.
Sir, what about the presentation? Actually, for both the subjects, we have prepared from third unit. So for analytical, should we prepare 2.2 as well?
Which one?
So for these analytical,
Yeah.
2.2 also we should prepare, because students have started preparing from third unit, na?
Yeah, third unit you can take from third unit, and now the presentation we will take from the Monday, 1st of the February, because your physical colleges is going to start from the Monday, Tuesday, 1st February. Okay, from that day we will take in our class only.
Okay, sir.
Okay, you prepare it well. You prepare the presentation having the 2 to 3 slides with the well pictures and all these things. Take the diagrams. If the diagram is there, you can take the diagram from the notes as well as you can take the diagrams from the Google also, as whatever I am taking from the Google like that. Okay, you can take if the there is a small content, whatever will be the small, you can take the additional information from the net. You can increase the number of slides. Okay, from two, I said minimum that will be the 2 to 3, or if you can take the 5 slides, 7 slides, 10 slides, no problem.
Okay, sir.